Neurips 2025. We are actually not going to be at Neurips, unfortunately. I got sick, so I chose not to go to save myself and also everybody else from contamination. But the point is, I think it's still very interesting to talk about a couple of things, and this the purpose of this particular episode. I think our goal with Neurips was to focus on world models. So to focus on the idea that you can have embodied AI trained in a virtual world, kind of like a like an emulator that emulates a chip before it gets taped out. So that same idea, I think, transpires in this particular Neurips, and I think it's fair to say that next year probably will be the year of embodied AI and world models. We've also heard the world models quite a bit in China. So this is definitely transpiring now from science into technology. And for those who are new to this podcast, here at Launch Capital Partners, we invest in fundamentally new concepts and engineering practices with large impact. So that's our mission. And the way we think about this is we look at the Venn diagram of science, technology, and entrepreneurship. And this is a good example of when science is turning into a technology. So the idea of science is, of course, you try, you do things, some might work, some might not work. And when it transpires into technology, so when the Venn diagram starts closing on technology and science, that is when something that has been working in the scientific realm, that has been successfully adapted, and maybe people are working on it, grad students are working on it, and now you have this ability to actually build a technology. And then the entrepreneurship part, of course, is when people actually take that and commercialize it. For example, Fei Li with her World Labs company. Nvidia is doing this with, I would say at least two of the three most important papers that they published in Neurips are about that. One is Alpha Mayo, or Alpha Mayo, I'm not sure, yeah, Alpha Mayo, excuse me, which is about self-driving cars. It's kind of like a foundation model of self-driving cars, where you have chain of C of C. What was it again? It's a reasoning model for robots, wheeled robots. So reasoning means if you're in a situation where you can't just make up your mind right away, where you can't just map the vision that you have to action, you need to reason. So they built an intermediary, a reasoning model. And I think that's pretty interesting as a concept. And then the most important part, as it's related to this episode, it's their foundation model for robotics, foundation world model for robotics. So this is the idea. It's a massive paper. There's dozens and dozens of contributors, and the paper is about how it is a presentation of a foundation model for robotics. So the stated goal is to have a in virtue world model that can train an embodied intelligence in virtue. So the robot can in virtue learn how to execute tasks, follow goals, and then transfer it from sim to real. That's the idea. There's a lot of technical conversation. For example, just how you tokenize something like that. Do you excuse me, do you build it based on video? Do you assume other sensor modes like haptics or sound? The paper's attached, so please do the reading yourself. But I think what I want to do here is just keep it at a big level. Why is this important, and what do we think can be done with this going forward? So this is not even a podcast. It's December 5th, 2025. This is Krim Delco. For the year, we're up to 18.3%. The market's up 16.8%. We're outperforming by 1.5%. So the concept of a world model as a foundation for embodied AI is that you have a replication of reality, a grounded simulation of reality. So this is not a explicit, hard-coded simulation of reality where we use traditional methods like explicit coding, physics formulas, and things along those lines. This is a model that is using prompts such as vision or language or both, and then creating realities based on those prompts that are realistic, consistent, physically realistic, and have real impact for an embodied AI. So that means that the robot learns how to navigate this reality in a way that it would also be navigating the real world. The best ground truth we have is the real world. That's the best ground truth. We have evolved as a species actually navigating the real world. I would argue we not just have evolved navigating the real world, but we've also evolved in fighting wars, and particularly conflict situations are always very prolific situations for human progress. That's just the nature of the beast. When you're complacent, when things are good, you don't spend a lot of energy in changing your state, and when things are more difficult, you have more incentive to investigate new trajectories, new counterfactuals. I think that's why intelligence usually drives forward in conflict areas. There's this saying by, I believe it's an American movie director. He said Switzerland has had 500 years of peace, and the best thing they came up with is the Cuckoo's Clock. And the Italians, they had the Borgias, they had civil wars and all kinds of things, and they came up with Michelangelo. In other words, when you have conflict, when things are tough, when there is controversy, usually good things happen. So in that context, I think the reason I'm saying that is I think we have, well, going back to first principles here, what is intelligence? It's adapting to the environment. Now, this environment, we have a real physical environment. Now, whether that is a simulation itself, who knows, but it doesn't really matter. There is something out there that we call reality. There is something that we have, which is the brain. We have a model. We have sensors, like particularly the retina and the eyes. And we're able to transform what we see, what we perceive from reality, into a model that helps us navigate the real world. So in that same sense, I think you could also argue that a world model could do the same thing. It could take actual, real physical properties, transmit them into something like a model that then helps an embodied agent navigate that model. Like if you go back to Jensen Huang's interview with Joe Rogan that he gave this week, which by the way is recommended. I would listen to it. It's a very good, interesting interview. So what Jensen talks about here is two things I think that stuck in my head. One is how the emulator saved Nvidia. And the reason the emulator saved Nvidia is because they were able to test a chip before they produce it. They were very short of money. They had to go to TSMC and say, look, we have a design here, and we just want to produce it. And TSMC said, well, don't you want to do some test runs and test it? And they said, no, we actually used an emulator, and that emulator was able to do all the stuff and the testing, and we think we're good. So that same concept, I mean, this is how Jensen survived as a company. This is deeply ingrained in his psyche, that you can have a physical representation of reality in virtual world and actually train or test or both a physical thing in virtual world, because he did it with Nvidia. It saved his company. So this is fundamental. This is absolutely crucial. And I think no matter how much people talk about this, no matter how much people are excited about world models and things, I think it doesn't take too much. I mean, you can kind of understand. You can understand the logic, but I don't think you can feel it. Like, unless you've been there and seen it yourself, unless you've actually experienced this type of thing where you had a physical thing that was tested in the virtual world and then actually worked in the physical world. Unless you've actually done this, I think it's hard to believe. So anyway, Jensen believes in this hardcore. Nvidia has published this paper, Foundation World Models for Robotics. It's a comprehensive paper that really goes from the data, like what kind of data do you need, what kind of tokenization you need. What does that mean? What does tokenization mean? It's another way to just ask yourself the question, okay, what is the best way to compress a certain video into its foundational entities, into its tokens, so we can then reconstruct or generate videos from that original ground truth video as we need it. So that's the tokenization part of it. The data, again, is like, okay, what kind of videos do we want? We have a whole section about curating videos. So you want to have action-driven video. This is something also Chelsea Finn said at CVPR 2024. I remember, like, curating the data itself. So, for example, having a lot of video where nothing happens, it's just, it's useless. It's you waste processing power. How about you just use you kind of define maybe algorithmically what are good video clips in the first place, clips where things happen, where things change, where agents actually have to make a decision, where there's counterfactuals, and then use those to train. So there's data curation. There's a section on that. I would say at this level, what we want to keep it high level. So we just, again, I think there is a lot of work at Neurips. There's a whole workshop on Saturday about this, about the world models for embodied intelligence. Tanya Fiedler is going to give a presentation, Chelsea Finn and others. This is very exciting. I think, Trevor Darrow from Berkeley, he spoke about this recently at a conference here at Stanford. Jitendra Malik's working on this. 2 years ago, I spoke with him about it. He said the most exciting work in robotics he thinks is actually on the simulation side. And what he means with that is that it's not the simulation per se. I mean, that on its own is, of course, a big leap forward. Imagine if you can simulate real worlds, what you can do with video games, what you can do with entertainment. So this is interesting stuff. But I think the most interesting part for us here is, again, it's the application to robotics, because with a functioning world model that is covering a good portion of reality, like the Emulator did for Nvidia when they tested their chip, you can then use, let's say, sample inefficient algorithms such as reinforcement learning. You can use something like AlphaGo Zero, the approach of a self-play agent that follows goals and isn't explicitly programmed to do certain things. You're not focused on tasks, you're focused on goals, which is the other big thing that I think Jensen said at the Rogan interview, which is that the future of human labor will be goal-oriented, not task-oriented. If your job is a task, you're going to be replaced by AI. But if your job is a goal, so instead of, like, if you're a lawyer and you see yourself as somebody who reads, the law and interprets the law, then that is a task. But if your job as a lawyer is to help people navigate complex environments and make them feel good and give them a peace of mind and things like that, that's your goal. And you need to be good at reading the law for that, but there's many other things you need to do, and that's still what humans will do. So I think similarly, we could say AI in the future, particularly with functioning world models, it will be the one AI which will win over the other AI will be the one that is goal-oriented. So if I want to have a home robot that is trained on sweeping the floor, that's fine, but I want to have a home robot that is trained to make me feel good, because having a clean apartment is part of making me feel good. That's much more powerful. So to summarize, again, world models are the path towards goal-oriented, from experience learning at low cost, at scale. That's the fundamental idea here. So in line also with Richard Sutton's keynote that he gave this week, learning from experience is a fundamental idea, but it's also practically feasible with world models. And Nvidia is particularly aggressively working on this, and that's maybe the main reason, but definitely one of the main reasons why we're very happy invested in Nvidia. Thank you.